In this lecture, we discuss capacitor and capacitance. Capacitor is a device that stores electric charge. It's a very fundamental circuit elements. They are commonly used in radio receivers, power supplies, almost all electronic devices you have, such as your computer, your phone.
This is a capacitor. It's an electronic component that acts like a storage tank. It fills up with electrons when energized, and it will then release them when the supply stops, or if the voltage level drops. We can use them to smooth out interruptions or fluctuations in the power supply, and we can filter out unwanted frequencies. I want you to imagine water flowing through a pipe. The water stops when we shut the valve, but if we let the water first flow into a storage tank, then we have a reserve. So now when the valve shuts, we still get a flow of water out of the pipe for a short duration. This is what the capacitor is doing. It stores electrons and then releases them when they are needed. But capacitors have a maximum voltage and some are polarized. So if we exceed this, they will burst.
Two conductors separated by a user insulator will give us capacitors. When the capacitor is charged, the conductors will carry equal magnitude of positive and negative charges. The conductors are called plates. A potential difference delta V will be there between the conductors due to the presence of the electric charge. The capacitance of a capacitor is defined as the following. If we charge the capacitor, it will carry charge Q, and the potential difference between the conductors is delta V. Then the capacitance is defined as charge Q divided by potential difference delta V. Okay. The unit for capacitance is 1 Faraday, which equals to 1 coulomb per volt, because capacitance is defined as charge per potential, and the unit for charge is coulomb. Unit for potential difference is volt. Faraday is a very large unit. Typically, the capacitance we use in our electronic device is 1 picofarads or 1 microfarads. Let's study parallel plate capacitor. When two equal area metal plates separate by a distance d, it becomes a parallel plate capacitor. It will produce uniform field between the two plates. We can charge the parallel plates capacitor by connecting the two plates to positive and the negative end of the battery. Then one plate connecting to the positive end of the battery will carry positive charge. The other plate connecting to the negative end of the battery will carry negative charge. The separation of charge now exists on the plates, and chemical energy in the battery has been transformed into the electric potential energy of the capacitor. We can derive a very simple equation to calculate the capacitance of a parallel plate capacitor. We know the electric field between two metal plates is given by charge density divided by epsilon naught, the constant we discussed, vacuum permittivity. And charge density is charge over area, so electric field is given by Q divided by vacuum permittivity epsilon naught times A. Q over epsilon naught A give us electric field. And then we know potential difference of a uniform field is given by electric field times D. Delta V equals E times D. So we can calculate capacitance by divide charge with potential difference. We'll have a cancellation of QQ, and then we end up with the equation. The capacitance of a parallel plate capacitor is given by epsilon naught area divided by D. To summarize, the capacitance of a parallel plate capacitor is given by epsilon naught times area of the plate divided by the separation of the plates. So C equals epsilon naught A over D. The flash of the camera uses a capacitor to store energy. When released, the charge gives us a very quick illuminating flash. Most of the keyboards we use for our computer also uses capacitors. The principle is the following. If we press a key, it will change the separation of the two plates. As such, the capacitance will change and the computer will recognize which key was pressed.
Is used in almost every electronic application. They are available in various sizes and ratings. Generally, their size lies between a millimeter to few centimeters. So, what it is? Well, it is a capacitor. A capacitor is a device which stores electrical charge. It consists of two parallel metallic plates. Plates are separated by an insulating material known as dielectric. When a voltage is applied on the plates, they store as electric charge. Plates are rolled in the form of a cylinder.